1s2, 2s2, 2p2. The element sublevel, the arrow pointing upward is first of all filled. For 1s, we have 2 electrons, the arrow pointing upward. For 2s, we have 2 electrons, the arrow pointing upward. For 2p, we have 2 electrons. Then we now fill the boxes, 2 boxes with arrow going upwards. Then, since the S2 has not completed its electron, then the shell in 1s is now filled with the arrow pointing downwards to complete the orbital, the shell. They followed by S2 to complete the electrons at the arrow pointing downwards. For oxygen, 1s2, the orbital electron is 1s2, 2s2, 2p3. For electrons of energy level filling, we have that the arrow pointing upward is first of all filled. Since the 1s, we have 1s, 2s, and 2p. Since the p has 3 electrons, we now fill it with the arrow pointing upwards first. Then, to complete the electrons in the element, in the shell, we now put the arrows pointing downwards for 1s and 2x to complete the atomic number. Then for neon, at orbital electron is 1s2, 2s2, 2p6. The elements sublevel is now, we fill, first of all, fill with the arrow pointing upwards for 1s, 2s, and 2p. Then, since the X is completely filled with 2 electrons, then the arrow pointing downwards is now filled. It's now filled into 1s, 2s to complete the orbital. Then the p has 6 electrons in the atom, in their shell. So we now have to fill the downwards arrow until there is 6 electrons in the boxes. We notice that there is 3 p orbitals in the p sublevel. How would the electron occupy these orbitals? According to Hort, the electron occupies each orbital singly first before the electron burst takes place, because the mutual repulsion exists between any pair electron. We can now represent the electronic structure of the next 6 elements, that is boron, carbon, nitrogen, oxygen, fluorine, and neon, as shown below. In a similar manner, the electron configuration can use orbital diagram to represent the first 20 elements of the periodic table. The electrons found in a given shell does not have the same amount of energy. This is because electrons move about the nucleus in different ways. The s electron moves about to produce the effect of a spherical cloud around the nucleus. Thus, s orbitals are spherically symmetrical. We can infer the shape of the electron cloud from the subsidiary quantum number I of an element. The p electrons move about the 3 axes x, y, and z that are at the right angle to one another. Thus, the p orbitals has the mark of directional character. 3 p orbitals represent px, py, and pz. Here's this s orbital. The s orbital has a spherical shape, as you can see in this diagram. The p orbital has a dumbbell shape. The dumbbell can be in the x-axis or in the y-axis or in the z-axis. Then this represent the p orbitals. For example, it can also be combined in this form as both horizontal, vertical, and the z-axis. Looking at the atomic structure of chlorine group 7, we have 1s superscript 2, 2s superscript 2, 2p superscript 6, 3s superscript 2, 3p superscript 5. From the first x block, we have one of the spine going up and the other one's going down. Then the second x going up and the other one going down. For the p, 2p, they only have two spines. First of all, they are all going up. Then, looking at their structure, you see that you have two s orbitals in the shape. So when they combine, they form this shape. One is going up, one is going down. Atomic structure of water. Water, as we know, as an element, contains H2O. Then, writing the atomic number, we have that 1s2, 2s2, 2p4. Then, from the blocks, we have that the 1s block contains one spine going up and the other spine going down because the s orbital is completely filled. Then the 2s block, one is going up, the other is coming down because of the field. The s orbital electron is filled. Then the 2p orbitals, then the first electron is filled before the second, the first arrow moving up one spine will be filled before then it's now completed by the downward arrow that has been seen. So looking at their structure, we have that the first s orbital already has x h h. Looking at the hydrogen is H2, so it contains two elements of hydrogen. So, and the oxygen is only one, but since the element is one, we have this as the structure. I hope you are following. This is what you see in the microscope. Isotopes. Isotopes are atoms of an element with the same atomic number, the same number of protons and neutrons, but different relative atomic mass because of the different number of neutrons. Atomic number determines the position of the element in the periodic table and also the chemical reactivity of the atom. Isotopes of an element therefore has the same chemical properties but different physical properties. The relative atomic masses of the element usually shown in the table of the relative atomic mass are really the weighted mean of the mass of the isotope of the atom of the element. This is why they are not usually whole number, but the mass number and abundance of isotopes of the elements.